Welcome to this Hazardous Industries group webinar with the fancy title of Understanding Brain-Centered Hazards. I'm really looking forward to understanding exactly what that means in the presentations. This follows on from our webinar on the importance of human factors in managing high hazard processes by Pippa Brockington in the autumn last year. And this is still available on YouTube. I'd recommend having a look at that. We will be having an opportunity at the end to answer some questions, maybe half a dozen maximum questions at the end. So if you can put your questions that you have in the Q&A at the bottom, in the Q&A box, not in the chat, that would be great. Yeah, so our two speakers are from a company called DEKRA. I've had dealings with them in a large coma site that I used to inspect, where they did some detailed analysis work, which was well regarded. They also have a strong record in process safety consulting as well as within human factors, so it's an ideal combination of the two. There has been a tendency to dismiss attempts to manage behaviours as worker bashing, with an over-focus on negative behaviours and punishment, or even to parcel off human factors as a separate topic other than the other process safety and hazard management issues. Now, the best performing companies have moved way beyond that and recognise the importance of integrating the consideration of people and their human characteristics into the whole safety management system. So we've got two speakers. Ian Stewart is the Director of Consulting at DEKRA. He was previously spent many years in operations in petrochemicals. And Christian Hopper is a Senior Business Development Manager. And he's got many years' experience of working with companies to achieve risk reductions. So I'm really looking forward to developing some of these ideas and hearing from both of them. So over to you, chaps. Thank you.
Thanks very much, Steve. And yeah, we're really pleased to have the opportunity to support the Hazardous Industries Group and provide some, I hope, thought-provoking content. I will pass over to Ian, who can get straight into the belly of the beast, as it were.
Okay, thank you for that, Christian, and thank you for the welcome as well, Steve. So good morning, good afternoon, and good evening, everyone, depending on the time zone that you're in. Very interesting topic that we're discussing today, which has to do with understanding brain-centered hazards. So for many years, we know there's been a missing, key in terms of for organizations to unlock sustained performance in reliability, safety outcomes, also with regards to the human brain. What we found as an organization is that overarching human error and hazard can only be effectively controlled if you actually align organizational culture, structures, and procedures with the functional realities and the limitations of the human brain. So that is by making your organizational system more brain aligned. So that's what we'll be touching on today, is how do you actually make your organization more brain aligned. When we think in terms of brain alignment, let's think in terms of where organizations might not potentially be brain aligned. It might be not being brain aligned in terms of by not considering the environment that people work in, not considering potential technical interfaces that people have to work with. As we see, a lot more automation come in, people working with a lot more AI, for example. Maybe people not having updated their operating procedures. There's another one where you might not have brain alignment on the operating procedures, which then leads to ambiguity, errors potentially on the part of individuals. Also looking at work schedules in terms of how we actually plan the work and how we put people to work as well, which also then considers shift patterns as well. Also looking at brain alignment around risk management. A lot of organizations have moved towards having risk management procedures that actually address fatigue as well. So if that's not considered in terms of whether people are working in strenuous circumstances, then obviously organizations leave themselves exposed to hazards and risks as well. And then ultimately, there's also another one that could be where organizations are not aligned around brain hazards, is just in the organizational culture. So with some organizations, it might be a topic they don't want to address, because if you have to address it, you have to do something about it. So that could also limit organizations in terms of moving forward as well. So with organizations that start to focus more on understanding brain-centered hazards, which we'll look at in a moment, you actually find when they do so, there's some benefits to them, so you actually find that where they develop people, and we'll look at some of the strategies for doing that later, it actually starts to increase workforce and leadership recognition on the hazards and the exposures that exist. Another thing that improves is that, people's in the moment decision making starts to improve as well. There was one of the implementations that took place in one of the countries where our colleagues work. They actually found that a person actually prevented a forklift truck from dropping over onto him, which would have resulted in a serious injury or fatality. And that was just by taking on the concepts of using the 7 different brain-centered hazards that we'll look at in a moment. What it also then does is, in terms of a benefit for organizations, it can start to increase team intervention engagement as well, where people, when they're considering slow, fast brain functionality and other brain-centered hazards that we'll look at in a moment, that they actually start to engage with one another out of it, in the concept of care. They do so for one another to make sure that whether a person is aware of something or actually encourages a person to use the other part of the brain that they're maybe not using. And so ultimately, we find in organizations that you do find that there's a reduction of errors, but there's also other benefits that we'll finish off with at the end of this presentation as well. So a lot of benefits to be gleaned in terms of understanding brain-centered hazards. So if we think in terms of, when we think in terms of brain-centered hazards, why have DEKRA sought to understand brain-centered hazards? Well, what we've seen is that in all organizations, there have been significant organizational safety improvements. But when you look at the trends, it seems to be that there's a decline in non-fatal workplace injuries. But you see that in a lot of organizations across the Americas, the UK, Europe, other parts of the world as well, is that a lot of the fatal injuries seem to have sustained themselves. And so we've also seen that there's been notable strides in terms of process safety improvements over the years. That could be containment practices or decreases in the frequencies or severity of loss of process control incidents as well. So there's a lot of areas in which industries have managed to start getting control. As I said previously, a lot of the safety metrics have leveled off, especially around fatalities, and data shows that when serious accidents or fatalities happen, is that one of the primary contributing factors, as mentioned by Steve in the introduction, is that 70 to 80% of operational incidents and high consequence accidents are contributed, or human factors are actually contributing towards that. So we see a lot of organizations are still finding it a challenge to actually address human factors. Sometimes it's a difficult thing to do because obviously we're talking about humans, we're talking about behavior, we're talking about decision making, we're talking about maybe a lack of skill set from the individuals as well. So it oftentimes in the industry, it can be a difficult topic to address. So as a result of that, we've decided that we'd start to look into what methods could we use to actually span the hierarchy of controls? What cutting edge methods could we potentially look into using as DEKRA, which could address these human errors that happen? So the area that we started to look into was human brain functioning, where we looked into the research that's been conducted on that. And we found that research actually provides a valuable roadmap where you can actually, if you have a roadmap, for fostering and sustaining high human performance, reliability, you can then start focusing on more accurately reducing the errors that are taking place within the workplace. The way we've gone about doing that is that we've actually started to harness the insights of neuroscience, and we've taken the insights from neuroscience. Because as we see, as years have gone by, there's different type of different type of technology that can be used to understand how the brain works, and so we've actually started to harness that research and apply it to the workplace, where people are potentially vulnerable and exposure exists and hazards exist. We've started to do that by focusing on what we call different brain-centered hazards. So you may ask yourself, what is a brain-centered hazard? So our definition of that is it's a situation where human performance errors have a high potential to cause harm, and to cause harm through the term that I've already referenced, through a serious injury or a potential fatality as well. As we've found through research that has been conducted by our organization on the brain, that the brain, it's a very intricate organ. It has, which has a high potential to actually cause harm through the decision making that it takes. So the brain significantly shapes an organization's focus to enhance human performance, reliability, but also it addresses gaps to reduce exposure in the workplace as well. So you find as you start to focus on the brain and you start to consider the limitations of the brain, because there are limitations on it, by focusing on the hazards and mitigating them, you start to deepen your comprehension of how our brains can be used, the skills that the brain can be used to master, and how we can actually then, use different methods to actually to stop errors happening and precipitating into serious injuries. So you're probably curious as to what are these different brain-centered hazards that I've just mentioned. We'll start off by the first one, and this is fast brain functioning. We'll probably find that in industry that most of the time when we're conducting activities, we use the fast brain. You've got the fast brain and the slow brain, and we'll talk about both of those in a moment. But if we think in terms of the fast brain, that's where you actually do things habitually in the fast brain. Most of the tasks that we conduct, or a lot of the tasks that we conduct, let me rephrase that, are actually performed by using our fast brain functioning. Within the fast brain functioning, that's where you do things habitually. Some people like to use the term, when you're working in fast brain, you're doing things on autopilot. So there's a lot of things that you do automatically or unconsciously. It doesn't take a lot of effort when you're using the fast brain. You may use the fast brain during routine tasks. It's things, as I said, that you do habitually, sometimes intuitively. And we also know that within the use of the fast brain, there's also sometimes an emotional or a reactive response. The counter side of the fast brain is the slow brain, and that's where you really have to slow things down and you have to do things more deliberately. You might put in a lot of conscious thought before you actually do the next step in an operating procedure, for example. So it takes, in using the slow brain, it takes a lot more effort. It's a lot more draining on the brain as well. And so if you're maybe performing a new task, let's say there's, it's a new task, it's quite an intricate task. You might find that as you start to do that new task, that's because you're doing it for the first time, it is taking a lot of conscious effort and you're feeling quite tired after the execution of that task because it's quite complex and you're having to go back, revisit the operating procedure, for example, and you're having to just do things methodically, step by step, as you work through the procedure. Maybe also while partnering with another colleague as well. So the slow brain also, it's more analytical. As where we previously said, the fast brain is intuitive. The counter side of that is the slow brain being analytical. And we know that the danger in terms of using the slow brain, which we have to use, is that oftentimes it can be impaired by fatigue, which we'll look at later on, or also illness or stress. So we're going to touch on that topic later. So when we're in fast brain mode, we're in fast brain mode probably as much as 50% of the time. So it's where we do things, as we said, we do things without thinking, or we don't have to have any conscious decision making. You just do it intuitively. And it's like if you've learned to drive a car, it's quite easy to just get up and drive a car. I remember when I worked in operations, if we were maybe isolating a piece of equipment with a lockout and tagout, and there's valves that needed to be isolated, you've turned so many valves in your life, if that's something that you've done quite frequently, that you just do it intuitively. But similarly, you might find that within an operating procedure, you sometimes have to move over to the slow brain functioning. So I used to work I started my career in petrochemical operations, but the first place I worked in was a power station. Just thinking in terms of high pressure steam, the steam in the pipes was 45 bar. You typically have to, when you're opening a certain valve, where downstream there is no steam in the valve. You'd have to do so, methodically, using the slow brain, slowing things down, because you don't want to create what they call steam hammers, or water hammers, as they sometimes use the term in industry as well. So the brain, when we go back to the brain again, in terms of fast brain functioning, you'll find that as we put people to work, the brain likes to use the fast brain because it likes to conserve energy. But also, in terms of conserving that energy, the fast brain functioning, it responds in 4/10 of a second, so it operates extremely quickly. And the fast brain, sometimes, in terms of thinking of limitations of people doing things at work that leads to errors or exposures in the workplace, is that sometimes the fast brain can react without thinking. So without a person consciously wanting to make mistake, just because the fast brain is kicked in, maybe the error has happened. When we talk about fast brain functioning and that being a brain-centered hazard, what you find with the fast brain as well, that oftentimes operates in what we call sketch mode. So in sketch mode, you've got the fast brain looking at colors, shapes, motion, looking at different visual perceptions. But as these changes happen and it's working very quickly, sometimes a person that's in fast brain mode could miss some important changes that have taken place, or they could overlook a weak signal because that part of the brain is operated too fast. And so you find that maybe the performance or the reliability, is not there, and the error then happens. So that was just touching briefly on fast brain functioning. But just to conclude that part on fast brain functioning, so as organizations do routine tasks and our brain is automated to use that part of the brain, oftentimes we'll do tasks without thinking, but that then leaves people vulnerable in terms of errors or exposure going up, or a potential accident happening as well. The second element that we look at is visual recognition. And that's where, with our vision system, it's guided by our brain. A lot of people think that you see with your eyes, but it's quite a challenge for people to actually be informed that actually you actually see with your brain. And so our vision system, as I said, is guided by our brain, and we can easily overlook important information if it doesn't stand out, or it isn't aligned with what the brain's looking mission is. So sometimes you can think you're looking for something, but you're actually not seeing it, because what the brain is telling us we should be looking for and what we're actually looking for is something different. We always use an example of that just by looking at the next slide. So if I were to bring up this image on the screen and ask you, just look at this lovely lake with lovely mountains in the background. It's a lovely place in summer that we'd probably all like to be for a little bit of respite, over the summer break. I'd probably ask, Christian, do you see a lake in front of you?
Yeah, it looks a bit murky, but yeah, I can see a lake.
Okay. So what happened there is that with individuals like yourselves, but also with Christian, I've actually referenced that a lake is in front of us. So because your brain has been told there's a lake in front of me, you start looking for the lake. Now, what you actually find then is that if we just change the background and actually zoom out on that and bring the front piece into the foreground, what you're actually looking at is a wall. It always has been a wall. But, because I reference it being a lake, the brain tells you it's a lake, so therefore you try to see a lake. Whereas, if we actually get a person to look, to change their visual recognition, then they can actually, where you go out with an open mind and you're not just thinking in terms of what someone else tells you should be looking at. And that could be in operations. It could be go out and just make sure that meter is on a value of 008, you go out there with a preconceived idea. I'm looking for 008. So you actually look at 008 and you see it as such, but actually maybe the reading is showing 000, and that then leaves our operations vulnerable. So just taking this picture and drawing it back into an operational example, we can oftentimes look at something thinking we're seeing it, but we're actually not seeing what the brain is telling us we're seeing. And obviously that then leaves organizations, quite susceptible to errors happening once again. So what we need to do is make sure that the expectations that we're setting in the brain are quite clear, because the brain will tell our eyes what to look for in terms of the expectations and influence what you think you're seeing, but then you're not necessarily seeing what you think you're seeing. So, so oftentimes people have to be primed when they go out to see something to make sure that they're primed in a morning safety meeting or in a job safety briefing, that they're primed to really look for the things that they need to be looking at. So that could be by planting certain seeds into people's brains before they actually go out there, so that they can address exposure and they can potentially overcome the hazards that are there in the workplace. The next one, and the third one that we'll look at then, is divided attention. And we know that divided attention very much goes along with distractions as well. What neuroscience has found, and many people, what neuroscience has found is that oftentimes people say, I can multitask, I can do multiple things at one time. Ultimately, neuroscientists have shown that you can't. If you think in terms of the areas of your brain that light up when they put sensors on them, you're only focusing on one thing at a time, but you're actually toggling between different parts of the brain in terms of one task and the other. And so oftentimes people thinking I can do multiple things at one time, it's not necessarily true. And in the workplace, that can be dangerous as well, especially when you're working on one task that requires a high level of attention, and someone else comes alongside you and you're distracted, or you're pulled away to another task. And so you're working on that task, but you're working on the other task as well. What studies have shown is that if a person is interrupted, it can take up to 50% longer to accomplish that task. And what we also find that when people are distracted or they've got divided attention, that oftentimes 50% more errors actually occur when the person is interrupted. So 50% less errors occur when people are uninterrupted. And we know interruptions can come from various forms. I just mentioned a person coming alongside you, but it can also be through sights. It can be, what's your eye drawn to when you're actually doing a critical task on a plant. Sounds as well can also be a distraction as well. And so there are various things that can actually cause people to have divided attention, and then thinking then that they can multitask, but ultimately they can't. So if you think even in terms of, how do we combat people having divided attention? Sometimes you have to remove distractions. I remember a good example I saw of where they actually changed the layout of the control room so that there was less footfall going through a control room, so that people's attention was not divided. That's just one example of it. But it's also important to educate workers, for example, in terms of them having an understanding of the limitations of their brain, and that when they're doing critical tasks, that they actually ultimately need to be developed to take better control. And we sometimes say that, if you had a switch, you actually have to turn up your level of attention as required on specific tasks as well. Another thing that can also divide people's attention, and that leaders need to be aware of, is that their messaging needs to be careful in terms of what people need to focus on and what is a priority. Because if a person says there's always time for safety, take your time, but then the messaging from the leaders is around, when are you going to get this done? When will you be finished with this? What's the status of that? And they start to apply the pressure on people, then obviously that could also lead to a divided attention as well. The next thing that we'll look at is memory. And it's quite interesting with memory in terms of we tend to rely very much on our memory, but there are some challenges in our memory. Oftentimes, if you're using your memory even in the workplace and you don't see that something is very meaningful, then your memory starts to not attach it as being that important. So if the brain doesn't value it as being important, you may become distracted, and then your attention goes to the things that are more important as well. So oftentimes if a person says, well, there's a written procedure for this, but the procedure is not that important to me, so you've told your brain that, it might be then when you actually orchestrate the task by using the procedure that you leave certain steps out. And that could be in not using a standard effectively, a procedure, or even a policy as well. We tend to, as individuals, think that the memory is like a vault. If you put something into the vault, it's there for life, but it's not necessarily there for life, because our brain, the way our brains work, they start to change sometimes what's important. And so as things have changed, you actually find then that maybe that information is not there, or the information that is there is not as accurate as could be. With a study that was conducted on when we can all remember what happened from the 9/11 incident when the Twin Towers were bombed. You know, a lot of people were interviewed on that. And what they found is that as time went by, 37% of the people that were interviewed actually changed some of the details that they were initially interviewed on, that they'd stored in their memory around where they were and what was actually happening on that day. 3 years later, 43% of them changed the details in terms of what they were doing and how they encountered that experience. So we can see that the memory sometimes, you know, not always as reliable. You know, sometimes we've got confidence, you know, in our memory's accuracy, but sometimes it can also be a poor predictor of recalling memories as well, which can be detrimental to the workplace if we have to accurately recall a procedure, as I previously said. Another thing then that we look at is social think. Some of you might have heard the term before. Sometimes people also like to use other terms when they're using the term social think. So when we think in terms of social think, what happens with social think, if we were to explain it, is what we can say about social think is that with individuals, in terms of human behavior, people have an innate desire to actually belong within a social group, you know, to be part of the team or the network that they're working in, which sometimes can make it difficult for people to speak up or, you know, to go outside the norms. And we know that this then, in a group situation or a team situation, can cause problems when the group is all headed down a dangerous path where they're exposed to exposure and a person feels that they can't speak up. Now, why does the brain not like social think? Because what you find is, as I said, we like to get along. So, you know, oftentimes a person won't speak up to another person when they're actually exposing themselves to risk, because you know, when you're actually challenging a person, it might be that that person or the person actually challenging the other person, their pride or their status is threatened. And you know, so our brain, the way, you know, if you have to go and challenge a person, your brain experiences that much the same way as it experiences physical pain. So if we ask ourselves, why don't I like to engage in challenging conversations? It's because we don't like to challenge peers, because we rather avoid the pain, and our brains like go into an avoidance mode where we avoid those discussions from ensuing. So oftentimes, because we don't want to have those discussions, what we also find with social think as well is that our brains also, they sometimes make assumptions about things. So you make assumptions, you make guesses, and you start to try and assume what's going on in the mind of others through what you're seeing. You're trying to assume what they're seeing, what they're thinking, what they're doing, and that can place limitations on us as well. As we know, in terms of strategies for overcoming social think, a big one that's many of you would be familiar is through the studies of the two social psychologists, Darley and Litaine, back in the 60s and 70s, was the bystander effect. So, you know, with social think, the more people you have in a group together, the less likelihood that one person feels the pressure to stand up and speak out. And so then a certain situation, a risk, a decision that's taken that impacts on the safety of people is negatively impacted upon. So we always have to think in terms of, you know, how can we combat social think? Sometimes we need to, I like a good strategy that was mentioned where a person says, you know, sometimes it's better to have the pain of speaking up than to go through the pain of watching someone get hurt. And that really resonates with me. You know, sometimes we've got to have those difficult conversations. Sometimes we also need to introduce having groupthink, and that could maybe be by altering who is actually leading the conversation. Sometimes it's good to sometimes defer to the person that's got the most expertise rather than maybe the most senior person that's heading the meeting. And obviously, it's good to encourage people to actually have challenging conversations and to appropriately challenge decision making as well, so that we can overcome social think as well. Communications are also very important in terms of overcoming social think as well. So we need to make sure that we're asking the right questions, that we've got, three-way communication, that we're doing cross checks on things as well, especially when we're doing critical and important tasks. So it should be that there's nothing, I like where people say there's nothing wrong with asking questions or stupid questions, because sometimes we need to do that as a group to challenge our critical thinking, so that we, realize the limitations that we have on the brain. Have we forgotten something? Are there memory limitations from the team in terms of orchestrating a task? Is it 5 years since they last did it? And so they need to revisit procedures, and as a team collectively work to ensure that no accident or injury happens during the orchestration of the task. The next one we look at is fatigue. And with fatigue, it's interesting, because with fatigue, you find that your chances of error go up significantly when you're fatigued. We find that people, in terms of if they're tired, they're less capable of solving problems. But you also find that people also, they sometimes can't think ahead. You find when people are extremely fatigued is that even their self-awareness of the level of their impairment is impaired as well. So they might say, I'm not that tired, I can do the task effectively, but actually in effect they can't, so even the way that they think might not be as effective as it should be. So what you find is with organizations is in terms of fatigue, there's some interesting data around fatigue and what we call brain impairment, where the people that actually study sleep cycles and so on have found that people that have only had 5.5 to 6.5 hours of sleep are twice as likely to make more mistakes. Now, if you've had less than 5.5 hours of sleep, you're five times more susceptible to make errors. So what we found is that, when a study was conducted worldwide, they actually found that 38 to 53% of people actually suffer from cognitive fatigue, which ranges between moderate and severe. So we've got tired people at work doing critical tasks, and they're working in fast brain functioning. And so that's where ultimately part of the recipe to combat that is actually, when you're doing those critical things, is to get people to move over, step back, slow down the pace, and actually to be purposeful in terms of using slow brain functioning as opposed to fast brain functioning. So when we think in terms of other things that some organizations do when it comes to, okay, well, we've got people at work that are fatigued, how do we combat that? Some organizations actually have a fatigue risk management policy. That's a best practice that some companies have put in place so that they can manage the fatigue. Some people, I've seen a good practice in an organization where for the night shift, they looked at what's the best part of the night for people actually to undertake a critical task, like the isolation of some key equipment. Excuse me. So they do it in those in the best hours of the night. What some organizations also do to combat fatigue is they actually give skills training to employees on how fatigue impacts on the decision making that they're making, and how to then, how they need to make decisions and how they need to manage their shift work, for example, by considering the impact that fatigue is having on them. So if people are educated, they're more knowledgeable around fatigue, then ultimately they themselves might be able to self-manage, or other colleagues might be able to manage them as well. Some organizations also provide work schedules that are free of structural fatigue. And that could tie into, for example, shift work cycles, considering circadian cycles as well, and ultimately ensuring that people have subsequent time to rest before they do undertake a task as well. We've come to our seventh one then, and that is stress and urgency. So it's interesting once again when we're thinking of the human brain, that the human brain experiences time pressure as a major stressor. And when we're in a stress state, the fast brain becomes our behavioral driver. And we know that, the fast brain, it's something where, if you're using the fast brain, you're stressed, and it activates fight or flight mechanism in a part of the brain that we call the anterior cingulate cortex, then, it's not necessarily beneficial. So what you find is that, that anterior cingulate cortex, which I just mentioned, when that kicks in, it actually blocks the activation of the slow brain, as I previously said, so that the brain conserves energy, and it actually keeps the brain fighting or staying in fight or flight. And so that's why we find if you are stressed at work, if there's extreme stress for long periods of time, it can be difficult to actually think clearly. We also know that then if we're working in fast brain mode, as I said previously, we're a lot more susceptible to making errors. We could have thinking errors, we could have memory lapses, or sometimes our thinking can literally be compromised. So as I said previously, it's important for leadership in terms of their messaging around stress and urgency, is that leadership messaging has a lot of power. It influences how people behave, but it can also block employees' thinking brains as well. So if you've got a leader that comes and says, I want you to do this like that quickly so that we can accomplish more, so we can get it done, finish it quickly. What's next? Let's get this task finished and we can move on to the next one. If you've got a hurry up, an urgency culture, obviously that can result in people continuously using the fast brain performance. And we know, as I said, it comes in with limitations. In fast brain, people also tend to be more reactive as opposed to proactive. They're not as conscious in terms of what they're always doing. It might be that they do some things thoughtlessly. It might also be based on emotions. So because I feel the stress of a supervisor or a manager on me, I go out and do something based on the emotion of that. And then it has a negative impact on my behaviors, which then lead to vulnerability, exposure, risk, and hazards as well. And that can also ultimately then result in errors happening. So it's to mitigate that, it's always important, when people say, take your time, think it through, focus on doing it right the first time, that people actually can, on those critical parts of tasks, use the slow brain, not fast brain functioning, and actually have the time to do it safely. So that's been quite a mouthful, so just having that takes us through the 7 brain-centered hazards. But the next thing that we'll look at is just in terms of, sorry, it's just jumped a slide ahead. I'll just jump back again. If we think in terms of organizations, what strategies do organizations need to use to actually mitigate these cognitive hazards that we've actually identified? The first is that organizations need to feel that they're actually empowered as organizations to enhance safety performance. So a lot of organizations actually build a comprehensive approach, maybe through a reliability roadmap that provides a framework for them to actually mitigate the risks that are presented by cognitive factors, so that they actually move their organization with the workforce and the leadership towards being in a place where they actually foster a culture of heightened awareness. It's a proactive approach, so people are starting to think more proactively. They're starting to think of what potentially could go wrong, the effects of fatigue, distraction, social think, and the other factors that we've looked at. They're starting to think of it, and they're putting actually strategies in place so that it removes the vulnerability and any cognitive biases they might have. The second element that we look at then in terms of to mitigate cognitive hazards is values-based alignment and decision-making. So organizations need to align the decisions and the core values to ensure safety is not compromised. So, you can't have different messaging coming from leaders, so if people are told slow down, use the slow brain and do the task effectively, you can't have people coming in with different values where they're actually rushing the people to get the task done. So to control brain-centered hazards, you need to foster a culture that prioritizes values-aligned decisions and empowers individuals to make values-aligned decisions by enhancing human performance and reliability. So people need to feel, in terms of their decision-making, what they decide to do, it's always supported. And that organizations have a lot of discussions around the different values through training, by talking about what's safe, what's ethical, and how we do that as well. The next one is then systems enhancement. So a lot of organizations then would craft their safety procedures to try and prevent brain-centered errors. That's by, for example, in an operating procedure, using straightforward language. I'll give a good example of that is where you might say, ensure that there's no significant delay. Now, what is significant? What's significant to Christian might be less significant to me, so you need to be clearer in terms of what that is. If you say to a person, make sure that you conduct the task safely. Well, what is safely? Safely to Christian might be different to what it is to me. So the operating procedures need to be enhanced so that there's no brain error in terms of how I read it. There's no ambiguity. And, whether it's one individual or another individual, everyone orchestrates the task in the same manner as well. Organizations are also finding that, in terms of system enhancement, by using diagrams, by using pictograms, even in operating procedures, it can provide a lot more consistency in the structure and ensuring that there's less chance of human error happening as well. The last one that we look at is then developing people in the skills to improve human performance reliability. And so, it could be that individuals are developed in how to do a risk assessment to evaluate the risks around their workplaces and in what part of a specific procedure, as I said, they need to actually engage in the slow brain thinking. It could even be, with a group of people that are maybe working on management of change, that, rather than rush into something and get something done quickly, that once again, the people are developed to consider, where the slow brain thinking needs to come in. Or even, we've seen it's even relevant sometimes to accident investigation is another place where slow brain thinking cannot be, needs to be considered and implemented as well. If you're telling people you've got the authority to stop work or halt operations, then ultimately, in terms of ensuring that happens, you need to ensure in an organization that if you say you can stop the work and halt the operations to mitigate a brain-centered hazard, then you need to make sure that the people are not only empowered to do so, but it actually happens as well. So just closing off that before we get into our questions, just to say, if we think in terms of brain-centered hazards, what could that look like? And what is DEKRA actually developed to actually cover some of those brain-centered hazards? This is a solution we sometimes use in collaboration with some of our other solutions that we have as well. Our psychologists have developed a method that they call making safe decisions. It focuses on 5 different elements where you actually get people to see more by noticing exposure and detect change, which then gets the brain functionality even higher. To think and interpret the implications of what you're actually seeing and to comprehend what that's telling you and what does it leave you vulnerable? Does it leave your team vulnerable? Then in the next step is what we actually do. So it's checking and verifying the workplace and evaluating performance in terms of what you as an individual are doing or what other people are doing. The next one is then the moving part of it, where it focuses on terms of how we or others use our bodies in terms of soft tissue load factors so that we don't injure ourselves. And then the last element is teaming, and it stresses the importance in terms of how you can have a teammate come and validate the perceptions that you have, challenge you in a respectful way, so that then you as a team collectively approach the exposure that exists in the workplace, where you've had those discussions in terms of validating the perceptions of what people have seen, what they've thought, and what they plan to do, so that it actually then reduces exposure. My last slide then is just around, you may be thinking, okay, so what type of organizations does this work in? We find it works in all sorts of industries. You can apply, you can apply having an understanding and addressing brain-centered hazards can be used in any sort of industry. We've done it in aviation, we've done it in trucking companies where we saw a 35% reduction in preventable collisions, but then also we've seen claim savings as well, significant. And manufacture, they were aluminium, 27% reduction in injury rates, and once again, worker compensation is down. But then they've also seen a reduction in environmental incidents as well, as people actually use brain-centric reliability and tools to actually consider what's happening with environmental incidents. A construction equipment rental company, 20% reduction, worker compensation down, and a higher level of safety engagement. A postal service, obviously moving packages and things around. Once again, a 20% reduction in harsh braking by 70 drivers, but also significant increases in self-reported pause work actions. Pause work actions are where a person stops and considers, before I proceed, let me think, should I use the slow brain? Do I need to visualize more? You know, is there anything that could potentially distract me? So it's using all these different brain-centered hazards that we've actually mentioned throughout the session today. And then they've also, with this postal company, they actually saw that people started to speak out more from what they were seeing and experiencing around serious injury and fatality actuals, and then started to prevent them as well. So there was an avoidance of crashes. There's other areas where you can also have benefits and spin-offs, and that could be, you know, through your production levels, through throughput, reduction in errors, absenteeism, attrition is another one, increased productivity, employee satisfaction as people look out for one another and consider the limitations of the brain and actually build in, you know, a roadmap to address that. So oftentimes you find there could be more discretionary effort from individuals. And ultimately, the key thing is why you want to use it as well is also that you want to see people not injure themselves. So that takes us to the end of the presentation side of it. In conclusion, I'll just say, you know, the brain is there. It's amazing, you know, through the neuroscience, as we said, how we now have greater insights into the functioning of the brain and how that it has an influence on people's performance. And so ultimately, it's for safety practitioners, it's for leaders in the workplace to actually influence their operational reliability to improve safety and its effectiveness, both organizational and process safety, by utilizing these 7 brain-centric hazards that we've looked at today. Okay, so we'll go into the closing piece of today, and that's just to field some questions.
Yeah, thanks so much. After you, Stephen, but I've got a couple of questions that I can bring up if as and when you want.
Yeah, no, I think if you want to go ahead and look at those, Christian. I mean, I think I'd just like to say thanks to Ian for that. I think one of the key things to this is having the right safety culture and wanting to actually look after your people in the first place. And so many organisations I've come across talk about putting their people first, and but I wonder often whether there is genuine care for people within organisations sometimes. And do those people, you know, is it just lip service when they say they put their people first, and that really they become expendable and almost an expendable resource in some companies? And I think you've got to really want to change that culture and start involving the workforce and valuing their views and opinions and wanting to change the culture of the workforce as part of that. But yeah, no, let's go ahead and look at these questions, Christian. Thanks.
Yeah, thanks very much. And I'd just say, I think, yeah, monitoring questions during a webinar is definitely a divided attention, brain-centered hazard that I'm encountering. So thanks to everyone who's asked some questions. Teo Chun Hong has asked, how can we draw these hazards as the root causes for incident investigation concretely, as we may not be professionally certified in terms of being, you know, a psychologist, neurospecialist, or whatever competency is required?
Okay, so I'll just give an industry example I've seen where what they've actually done is they actually use the different brain-centered hazards. They build it into, say, top set accident investigation methodology that they use, but then they'll give descriptors. Now, you know, there's descriptors for what the type of hazard is. So there's actually some things that you can anchor to. You could sit down with an organization and you could say, in this instance, from the individual, how much time was allocated for the task? Well, typically it should be 20 minutes, but by the time the accident happened, the person was close to the completion of the task and only 6 minutes had elapsed. Okay, so what you could think in there in terms of that, then the person was rushed to do the job. So you need to ascertain, where did that rush come from? Was it was the pressure on the person? Was it actual pressure from an outside source, or was it just the perception of the individual? I need to get this done quickly. So so it's listing them, building anchors in that actually support them, so that it's quite clear to everyone within that organization. And that could also be with the help of external psychologists, where they actually they do an assessment of your accident investigation program, and then they help you to develop what the different anchors are, so that informs more consistent decision making. But it's also, there's an element of the questioning techniques you use in accident investigation, and actually asking the person, how are you feeling on the day? How did you sleep the last night? Were you feeling fatigued? And it's also people, it's dependent also sometimes on the openness and the transparency of people in terms of sharing with the accident investigator, how they were feeling on the day, because then that could be a contributing factor towards the injury. Good question.
Yeah, very good.
Can I also add on that? Sorry, there are lots of sources of guidance on human factors, and it is a competence like any other that needs to be developed within a company. I mean, there's things like the Energy Institute guidance, for example, and others on say Health and Safety Executive's website. So yeah, it's a competence that needs to be developed. Thanks.
Yeah, agreed. Initially, Antonio Javier has asked, what does human performance errors mean? Is there a taxonomy or a model that would help us to look at this?
Okay, we've got a model. I won't share it on this specific call, but if we can take a note of Antonio's name, then we, in terms of some of our materials, we actually have a model that we use that actually addresses human performance.
Great. Okay. In terms of another one, Terry has asked, with an aging workforce having to deal with the urgency mode that younger managers tend to focus on, how do we work within this?
Okay, so that's I find that quite an interesting one, because I'm respecting what you're saying, but I know that there's some older managers that have that same sense of urgency as well there, Tony. What we find is organizations, if you actually are to address, as I said previously, if you are to actually come up with a strategy in terms of how you plan to address brain-centric hazards, if you're to empower an organization to enhance safety performance and bring those improvements, what you need to sit down with is developing a governance team that actually look at decision making in terms of what are the expected behaviors around decision making, and that irrespective of whether you are a young manager, you've got years of experience, or you're new to the role, or you've been in the role for many years, that there are consistent practices from individuals in terms of how they actually drive human performance as well. Because that's what you want. You want consistency in practices, but otherwise it continues to leave the organization vulnerable. So that's the other side of things that we sometimes look at when we work with organizations. We look at brain-centric hazards, but we also look at leadership practices. We look at practices that actually then contribute towards serious injury and fatality precursors as well. So and I like what Steve said about the culture. What is the culture actually doing in terms of what's our messaging? Take your time to do it safely, but we actually then effect rush people. You need to, those individuals, there needs to be consequence management of them, because they then set the tone, and then there's mixed messaging that goes out.
Very good. We've got another one from Amy. How does brain-centered hazards differ from human factors analysis?
I think myself and Christian have looked at some of the human factors analysis, and we find there's a lot of similarities. A lot of the words are very similar. With this piece, it's been very much focused on the neuroscience and what's come out of it, and then linking that to workplace exposure and reducing vulnerability and reducing workplace exposure and error as well. But there's definitely a correlation between the two.
Very good. And I think we've got time for one last one before we sign off. Shravan Farmer has asked, fast and slow brain functions are really fascinating. Can you give more examples of interrupting fast brain functions? You mentioned stop and pause, four eyes check, any others?
So either the individual can do it to themselves. Okay, so yeah, what some organizations might potentially do is they might word it into an operating procedure. So they might say that when you're orchestrating this task, you must use an operating procedure. And they might even list at a certain part that these are the type of things that you typically do quite quickly. When you get to the following piece, it might actually, within the procedure state, now stop, step back, go into slow brain thinking, slow brain functioning, and do the following things meticulously, slowly, well thought through, calculated, comprehensive, so they're actually prompting where in the task a person actually needs to do it. Or they're actually developing people that supervise other people also to get them to consider having those discussions, or even at a peer-to-peer level for people that are not supervised, for them to also have those discussions around at what point should I step in and have that discussion with you without distracting you, but just making sure you're well aware of what you visualized, what you've thought you've seen before you actually start to orchestrate the task.
And I also recommend a book to everybody. It's the Checklist Manifesto by Atul Gawande. It's a really good read. And I'm not a health and safety geek that usually likes to read this sort of stuff in my spare time, but that was a really good read and really interesting. So that's got lots of examples of how these things impact on organizations and how safety culture can be improved.
Yeah, thanks a lot for that, Steve. Yeah, we find that even there's some of the companies we work with, they do what they call a 5 risk assessment to evaluate the risk, but also evaluating the risk based on slow brain thinking before they actually so that informs their decision making before they actually orchestrate and continue with the task.
I think that's all the amount of questions we have time for if we're going to be on time for this. I think we're happy to collect any questions and try and provide some responses via the group down the line. But yeah, thank you so much, everyone, for allowing Ian and I to speak at the event. Hope it's been valuable, and pass you back to Steve. Thank you.
Yeah, well, no, thank you very much for that. Excuse me. Yeah, some really interesting stuff there that came out for me, particularly in terms of some of the statistics on fatigue and things like that, in terms of the numbers of the risks, the risk errors and stuff that arise from that. I mean, that came as quite a shock to me, how getting less than 5.5 hours sleep has such a massive impact on things. So yeah, some really interesting insights there. Thank you to both for your time. Thank you to everybody for attending. I guess, as with other webinars, we will be looking to put this recording onto YouTube at some point, so you can recommend it to other people or go back and re-watch some of the stuff that's been covered. But yeah, thank you very much, everybody.